Stop, this doesn't make sense. Hold up, wait, who are you? I am you. I am me. No, sir, you are you.
Hi guys, welcome back to my YouTube channel. So my name is Sithole, and in today's video we are going to be doing set G of test 4. So let's get right into it without wasting time. Please don't forget to comment, like, and subscribe. I'd also like to thank everybody who attended the bootcamp that I hosted, and hopefully it was awesome and you guys learned a lot. So let's get right into today's content. So the first question says, the prices of one-bedroom flats in a certain area in Johannesburg are normally distributed with a mean price of 320,000 and a standard deviation of 60,000. So from this question, I find the subject of my population, right? I find the subject of my population, and it is the prices of flats in Johannesburg. So I'm just going to denote X, right, as the prices of one-bedroom flats. So when I say X, I mean the prices of one-bedroom flats, right? And we are told that X, these prices follow a normal distribution with a mean of 320,000 and a standard deviation of 60,000. So remember, in the bracket, you need to have your variance, right? So since I am given the standard deviation, that means I'm going to read from the Z table, right? And I'm going to show you guys how to do that. So let us go on and read the question. The question says, the probability that a randomly selected flat in this area will cost more than 245,000 is. So they are talking about the cost. They are talking about X. So what they are asking is the probability that X, the cost, the price of the flats, is more than, so is greater than 245,000, right? So that's what they are asking. So I am at X, but I need to read from the Z table. So how do I do that? I have to standardize, right? The process to move from X to Z is generalization. How do I generalize anything? I subtract the mean and divide by the standard deviation, right? This is how I standardize. This is how I standardize. So let me do that. Probability that Z is greater than 245,000 minus 320,000, all divided by 60,000, right? This should give you, let's see, 245,000 minus 320,000 all over 60,000. This should give you negative 1,25. So the probability that Z is greater than negative 1,25 is equal to what I'm looking for, right? So remember, on the Z table, the standard form is less than. So I need to change this inequality sign of greater than to less than. How do I do that? I just put the inverse of the sign and also change the sign. So this is going to be the probability that Z is less than 1,25, right? And now I just had to read from the table. So let me first teach you guys what this means. So this is a Z score. What is on the inside is a Z score. And what I'm looking for on the outside is a probability. Probability. Right? So let us read from the Z table. So the Z table moves from negative 6 to positive 6, right? And I am looking for a positive number. So forgive my Z table, it is very filled with a lot of pencil. So I'm looking for 1,25, right? So the first column gives me the first decimal, whereas the first row gives me the second decimal. So I'm looking for 1,25. So the first decimal is a 2, right? So I have to go to 1,2, but I'm looking for 1,25. So I go on and I go to, okay, I don't want to make mistakes. Let's just use this. So it's going to be 1,2, right? 25. So it's going to be 0,8944. So this probability is equal to 0.8944. Right? So let's go back to our question and see which option that was. That was option A. So the correct answer is therefore A. Okay. Let us move on to the next question. But before we do that, I just want to put my sticky notes on my formula sheet so that I am able to move it to it in ease. So, okay. Please bear with me, guys. Okay. Also need to get to my sticky notes. Okay. Sorry about that, guys. So I just wanted to be able to move to my sticky notes in ease. So let us look at the second question. So remember, question 1, the statement that I read deals with question 1 to 3, right? So the second question says 40% of flats in this area cost less than. So they're giving me a percentage, they're giving me a probability, and they're asking about the cost. But remember how I denoted the prices of the bedroom flats? I denoted them as X. So they are actually asking for an X value. So if we write it in how we know it, probability that X, right, costs less than, so I have a less than sign, this price of X, they are telling me that this probability is 40%, right? So I do what I do. What I usually do, I first standardize so that I move from X to Z. So it's going to be the probability of Z being less than X minus 320,000, over 60,000, right? And they are telling me that this is equal to 40%, which is 0.4, right? So they are saying that I have a Z-score, and this Z-score goes with a probability of 0.4. So now I need to go look for a probability of 0.4 in my Z table, right? So I need to look for a probability of 0.4 in my Z table. So let's look for it. 0.4, okay. I'm seeing a number that is close to 0.4, but there's no 0.4 here, right? So you have this number 0.0359, and you have another number that seems to be close to 0.4, which is 0, sorry, am I looking for 0.4 straight? Oh, I'm not looking for 0.04. Okay, wait, let's look for it again. 0.4, 0.40, okay, 0, okay. I have a number that is close to those, and that number is, I'm not sure if you guys can see this, but let me try to like bring it closer to you guys. So I'm looking for 0.4, right? But I don't have the probability of 0.4 in my Z table. So I look for the number that is closest to 0.4, right? So if I check properly here, the number that is close to 0.4 is 0.4013 and 0.3974. So now I need to know which one is the closest to it, right? So you can just do this quickly and say 0.4 minus 0.4013. Sorry, shouldn't have had a 0. So the first one is 0.0013 away, and the other one is, let's see, 0.3974. So the other one is 0.0026. So which one is the closest one? 0.0026. Which one is the closest one? This one is the closest one. So even though you got a negative here, you will find the absolute value of this, right? And then conclude that the one that we calculated first is the closest one. So the closest number to 0.4 is 0.4013. Okay, so now I have the probability, right, closest to it, but I need a Z-score. So I'm going to see which Z-score corresponds to this probability. So the Z-score that corresponds to this is negative 0.25. Okay, so it's gonna be equal to negative 0.25, and I say that this Z-score is equal to X minus 320,000 over 60,000. So now I need to solve for X. So X is gonna be equal to 305,000, right? And I think that option is option B. So B is our answer. B, right? And then let's go on to number 3. So number 3 says, an agent has 4 flats. He has 4 flats that are for sale in this area. So N is equal to 4 because you have 4 flats that are ready to be sold out, right? The probability that the average price, remember X is talking about the prices, right? Not the average prices. X is talking about the prices. So I need to denote the average prices now differently. So they are saying the probability that the average prices of the flats has for sale exceeds 305,000, right? So let us work with that. So they are saying the average is X bar, right? And you're talking about average prices. So this goes back to the central limit theorem, case number 1. So the central limit theorem says when X follows N, we have 320,000 and 60,000 squared. Therefore, X bar is going to follow N 320,000 with the 60 squared over N. N in this case is 4, right? So now I need to find the probability. I'm not sure if you guys can still see. Let me check. Okay, yeah, you can. So now I need to find the probability. Okay, sorry. Now I need to find the probability that the average price exceeds 305. So the probability that X bar is greater than 305,000 is equal to. So I do the same thing. I need to move from X bar to Z. How do I do that? I standardize. So the variance is known. So even here, I'm moving to the Z table. Excuse me. I am moving to the Z table. So it's going to be the probability that Z is greater than 305,000 less 320,000 all over 60,000, right? Then I'm going to find the probability over 60,000, okay, over the square root of 4. Sorry about that. So let us see what that gives me. 305,000 minus 320,000 all over 60,000 over 2. So that gives me negative 0.5. So its probability of Z being greater than negative 0.5, right? I have a negative answer, and on my Z table, I need it to be less than. So what do? I turn it around, and I give it the inverse sign. So I had a negative 0.5, so I'm going to have a 0.5, and I need this probability. So I go to my Z table as usual, and I find the probability that corresponds to the Z score. So this is a Z score. I'm looking for a probability. I find the probabilities on my Z table on the inside, right? And I find my Z scores on the outside. So I have a Z score. I want the probability. So I go to 0.5. So it's going to be 0.50. So the probability that I have is 0.6915. 0.6915. Let's see what that corresponds to in the question that we are doing. So that corresponds to A. So therefore A. Right, guys? I hope you guys are still following. So let us do the next one. So we are now moving on to number 4. Just want to see how far you guys can see what I'm doing. All right, so let us go on to number 4. So number 4 says, suppose that the number of online orders received by a shopping franchise in a 24-hour day follows a Poisson distribution, right? Suppose that an order has just been received. If it is known that the probability that no order is received for at least 12 minutes is 0.2, determine the expected time before the next order is received. Okay, X is the number of online orders received, right? And they are telling us that X follows a Poisson distribution with our lambda per 24 hours, right? So, suppose that an order has just been received, right? If it is known that the probability that no order is received for at least 12 minutes is 0.2. Determine the expected time before the next order is received. So here they are mixing Poisson and exponential. So I'm just going to say it again. The relationship between my exponential distribution and my Poisson distribution is a very important relationship. So for the Poisson one, so Poisson and exponential are going to share lambda, right? Just make sure that, for example, here they are saying per hours, but when they are talking about exponential, they are saying per minutes. So make sure you do your cross multiplication correctly. The relationship between your Poisson and your exponential is the fact that the Poisson one is my rate of occurrence. It's telling me how many times something is going to occur. Whereas the exponential is the waiting time between when the first occurrence occurs and the next occurrence. So in this question, they first told me that x follows the Poisson. So what is the waiting time going to follow? Going to follow exponential, right? So they tell me that if it is known that the waiting time, because they said here that if we know that no order will be received for at least 12 minutes, that means I'm going to wait for at least 12 minutes until another order has been received. So if it is known that the waiting time is 12 minutes, and the probability is 0.2, I need to find the expected time in minutes before the next order is received. So they are asking for the expected value of x, right, under exponential. The formula is going to be given in your formula sheet. However, the expected value under exponential of x is going to be 1 over lambda. So they gave me an x value and they gave me a probability. So I need to calculate my lambda so that I can find my expected value. So if you go to your formula sheets, you'll see that the formula for fx, so we have fx formula and we have a big fx formula of 1 minus e to the power of negative lambda x. So with this formula, you use it when you have a less than, right? In this one, use it when you have a greater than. So here I have a greater than. So I want to use this formula because it's the one I'm used to. So I'm just going to find the complement of that. So if the greater than is giving me 0.2, what is the complement going to give me? The complement is going to give me the remainder, right? It's going to give me 1 minus 0.2. So to have the probability that x is less than 12 is going to be 1 minus 0.2, which is 0.8. Right? Now I want to substitute what I have into the formula and solve for lambda. So I am given the probability. So it's going to be 0.8 is equal to 1 minus e to the power of negative lambda. I'm given my x value as 12, so times 12, right? And then when I solve for this, remember to get rid of an e, you need to put your ln, right? So I forgot what this e is called, but yeah, if you want to remove this e, you're going to have to say ln, because ln is log e, right? So it's going to cancel the e's and you're going to be left with whatever the ln of 1 over 5 is equal to negative lambda times 12. Then you divide by negative 12, this is what you get. So this is my value for my lambda. However, the expected value formula says 1 over lambda, so it's going to be 1 over this answer, and the amount that I get is 7,456, and that corresponds to C, right? So let's go on to the next question. So this is number 5. So number 5 says, it is assumed that the daily share returns are normally distributed. So I'm talking about the daily share returns. They are telling me that X follows a normal distribution. And they say that a financial analyst wishes to determine a 95% interval for the mean daily price for the mean daily return for a particular share listed on the JSE. A random sample of 9. So they didn't give me my mean, but I don't need my mean for any confidence interval. However, I need to know whether the standard deviation is known or not. In this case, it is unknown. So meaning I'm working with case number 2 on the table. I will show you guys that case. So they want a 95% confidence interval. So they want a 95% confidence interval. That means my A is 5%, right? Because A is the error. If I'm 95% confident, then the remainder of the percentage is my error. It's my significance level, which is A in this case, and it is equal to 5%. So they say that a random sample of 9 daily shares, so N is equal to 9, gave us this following data. So they gave me a data of 9 percentage returns. So you have to use your calculator to find the sample, right? And then work with what you have. So before we do that, let us go back to our formula sheet. So on your formula sheet, so sorry, I use my formula sheet so much that they are a whole mess. So this is my formula sheet, right? So if you check here, it says confidence interval, yes. So where the population variance is known, I use this one. Where the population variance is unknown, I use this one. This is the case I am working with. So let me just write down the formula so that I know what I need to calculate. So I need an x bar. So I need x bar plus or minus t n minus 1 with a over 2 multiplied by s over the square root of n, right? So that's what I need. So let's go back to the question. So in the question, I'm given values, right? Meaning that I need to use my calculator to calculate my mean and my sample standard deviation. So let me remind you guys how to do that again. I'm just going to clear my calculator, and then I press stats, press the first option, and then I put my data. So the first one says 12.5. The second one says 3.8. The next one says 6.9. The next one says negative 15.4. The next one says 7.5. The next one says negative 0.3. The next one says negative 9.1. The next one says 1.8. The next one says 6.0. Right? That data should be equal to 9. N is equal to 9, right? Then I press AC, shift, stat, number 5 for variance, and then 2, I get my x bar. So this is the value for my x bar. So my x bar is equal to 1,522, etc. I'm just going to store this under A. So I'm going to be like answer, shift, RCL, store under A. So it's stored under A, and I just write A on top, right? Now let me calculate my standard deviation. So I'm just going to be stat equal to AC, shift, stat, number 5. And then I'm going to calculate number 4. Okay, so that is my standard deviation, 8,7535. I'm just going to store this under B. So answer equal to shift RCL B, right? Okay, I've stored it under B. Let me find my T n minus 1. These are my degrees of freedom. I have n is equal to 9. So my degrees of freedom are 8. So degrees of freedom is 8. So what is T? 8 for a significance level of 5% over 2. What is 5% divided by 2? 0,025, right? So it's going to be of 0,025. So I need to go to my T table and read, right, the T table. So my degrees of freedom are 8 because it's 9 minus 1. So I go to degrees of freedom of 8 and I look at 0,025. So 8 and 0,025 is 2,3086. It is 2,3060, sorry. Right? So my n is 9. So let me just substitute into this formula and find our confidence interval. So my x bar is the value of A, the value stored under A, plus or minus 2,3060. Hope I didn't make any mistakes. The value under B over the square root of 9, which is 9, right? And then let's work this out. So it's going to be alpha A plus 2.3060 times B divided by 3. So I get 8,25, right? So let's see if I don't make any mistakes. Because, okay, 8,25. So it's going to be 8,251. Okay, they wanted it to 2 decimal places. Then I find the minus. I get negative 5,21, right? So the correct answer here is A. So this is my 95% confidence interval, right? So let us go on to question 6 and 7. I just want to make sure you guys can see properly. I'm so sorry. I hope you guys were seeing what I was writing. Okay, so let's go on to question 6. So question 6 says that 2 manufacturing plants produce car components. The number of defects per day, recorded in each plant during a 7-day period are as follows. So my N is 7. So they give me 2 manufacturing plants. Those 2 manufacturing plants do not affect each other, so they are independent. So I take note of that. I'm working with an independent case, right? All right. So for independent cases, what are my cases? What cases do I have? So if you go to your formula sheets, the cases that you have for your independent is that you have h0 being mu1 is equal to mu2, and h0 being mu1 minus mu2 being equal to 0. So this is your h0. This is how you should define your h0, right? Okay, let us see what they are asking though. So they are asking to test the hypothesis at a 5% level of significance. So my A is 5%, right? So test the hypothesis at a 5% level of significance that there is a difference in the number of defects recorded per day. So they want it to not be equal, that there's a difference between the two, right? So if there's a difference between the two, that means that for my test statistic, I need to have, they didn't say it's greater than, they didn't say it's less than, they said that it's different. So it could either be greater than or it could be less than. So I need to divide my A, the area, by 2. So my A is going to be divided by 2. So this is going to give me 0,025, right? And then they say which of the following statements is incorrect. So so I'm looking for an incorrect statement. The appropriate test to test this is h0 is mu1 minus mu2 is equal to 0. That is true. Versus that h1 remember is the alternative hypothesis, right? It's what someone is claiming to be true. So what are they claiming? They are claiming that mu1 minus mu2 is not equal to 0. That is true. The second one says the absolute value of the critical value is 2,1788. So let us calculate the critical value. This is step number 2 of your hypothesis testing. Critical value, right? So I'm looking for the probability. Remember, I'm reading from T, right? So the independent ones, you read from T. So T is greater than T for this part, and the probability that T is less than T, right? I am given an area of 0,025. So I'm looking for probability that T is greater than T when I have 0,025, same as this side, the probability that T is less than T when I have an area of 0,025. Then guys, so remember we're talking about independent events. So my degree of freedom has to be for the first one, right? So the first plant, so in this case the first plant has 7, the second plant has 7, so it's supposed to be 7 plus 7, 14, and then minus 2. So my degrees of freedom are not supposed to be 6, and I'm sure that answer was going to be there. Okay, please don't make the same mistake as me. So the degrees of freedom are actually 7 plus 7 minus 2, which is 12, right? And then now I read from 12 degrees of freedom. So if I read from the 12 degrees of freedom, and I am reading 0,025, I get 2,1788. So yes, so that is true. So B is true. So C says the test statistic is negative 1,7823, right? So let's see if that is true or not. So how do I test the statistic? I go to my hypothesis testing for independent, and this is the test statistic they gave me. So I just substitute into the formula and see what the amount is that I get. So T is equal to first x bar minus the second x bar minus 0. If they don't define it for you, whatever the first table is, use that one. 1 over n1 plus 1 over n2. Righty, so meaning that I need to calculate my first x bar, my second x bar to be able to use this. And I need to calculate my S star. So I'm just gonna go slow here because a lot of people make silly mistakes here. So hopefully I also don't make silly mistakes so that I can help you guys. So S star squared, this is S star. Should say this is a standard deviation, but I need S star squared. It is equal to n minus 1 over S squared plus n minus 1 S2 squared all over n1 plus n2 minus 2. So to find the S star, I need to square root both sides. There's going to be the square root of this and the square root of this whole thing, right? So yes, let us do this calculation. So I'm going to calculate my x bars for the first plant. So I'm just going to clear everything that I have on the calculator. So it's going to be stat variance 1. So the first one, 12, 6, 3, 8, 12, 7, 9. 1, 2, 3, 4, 5, 6, 7. Okay. Then AC shift stat. Okay. Shift stat 5. So the first X bar, so X1 is equal to 8,14. I'm going to store this under A because I don't want to be rewriting the whole decimal, right? Let me calculate my X. Okay, my S1 is going to be equal to, so I still do what I have to do on the calculator. Find number 4. So I get 3,2366, right? And then store this under B. Shift RCL B. Okay, and then to find the S squared, right, I'm going to have to square whatever I got as my standard deviation because they want the variance, right? So I have for the first X's, so let me go and calculate for the second plant. So the values that I have are 11, 13, 15, 6, 10, 9, and 8. Shift stat 5, and then I have number 2, right? So my X2, X bar 2 is 10, I hope you guys are doing this question with me. I'm just going to store this under C. So it's going to be answer is equal to RCL C, right? And then S2 is going to be stat equal to AC shift RCL. Hope I didn't make any mistakes here. Number 4. So 3,0394. I'm going to store this under D. Answer is equal to RCL D. So I'm going to mark myself because I was writing this test. So I'm just going to mark myself and see if everything was right now. Okay. So I stored that under D. Let's calculate this now. So we have S star is equal to the square root of n minus 1. So my n, remember, is 7. So it's going to be 7 minus 1, 6 times for the first one, b squared, right, plus 6 times d squared all over 12, because it's going to be 14 minus 2, 12, right? Excuse me. So I have 6 times b to the power of 2 plus 6 times d to the power of 2, and then divide by 12. So it gives me 9,8571, and I'm going to store this under X. So answer shift RCL stored under X. Okay, now let's substitute everything into our formula to find out T. So T is equal to, my first X1 is A, so it's going to be A minus C over my S star is X times the square root of 1 over 7 plus 1 over 7, right? So let's A minus C, right, divided by X times Y. Okay, so I get a negative 4067. So that statement is incorrect. So I'm gonna say C. I think I made a mistake here, but we'll see when we mark. Sometimes you make a mistake, but it works out for you in your favor, especially when you're calculating a false answer. Oh, this is negative 0,40. Okay, that was a long calculation, and I do have a feeling that I made an error. But let's see what happens if we mark ourselves. Okay, the error won't be in the content. It will probably be in the calculator used, because this calculator doesn't have a division sign, which makes it a bit hard to calculate. So let me move on to number 7. We are almost done, guys. Number 7 says, which of the following, remember we're still talking about what we read about the 2 manufacturing plants. So number 7 says, consider the following statements. The number of defects follows a normal distribution. 7, they say consider the following statements. The number of defects follow a normal distribution. Yes, that's true. So that's an assumption we have to make to be able to use independent cases. Secondly says the population variances are unknown but equal. Yes, that is true as well. For the content that we're covering, we are assuming that the variances are equal even if they are unknown, right? The population variances are equal. The average number of defects follows a normal distribution. No, because we are reading from the T table, so they can't be following a normal distribution despite them being unknown, because remember I said I is true, so we're reading from the T table, so that's not true. Due to the essential limit theorem, the average number of defects follows a normal distribution. No, doesn't. Because the population variance are unknown, it follows a T distribution, not a normal distribution. So the correct answer is B, right? Only I and I. Let's finish up, guys. So we have question 8, 9, and 10 to go. So a manager of a large factory believes that the average daily production at a factory has declined in the last year. The factory is supposed to produce 260 units daily on average. So they believe that it has declined. So H1 is that the mu has declined, right? Okay. The factory is supposed to produce 260 units daily, so it's less than 260. A random sample of 36, so n is equal to 36, yielded an average, so it yielded an average, so x bar of 252 units per day, and a standard deviation, and s of 24. Assume that the daily production of the factory is normally distributed. The appropriate hypothesis to test is, okay, so a manager for a large, okay, so H0, yes. So what is our H0? H0 is our mu. Now mu in this case is 260, right? But they are claiming on H1 that mu is less than 260. So I need to find that option, and that option is D. Therefore, D. Okay, question 9. Question 9 relates to question 8, right? The conclusions for the appropriate test is that there is insufficient evidence to conclude that the average daily production has declined at the 10% level. Okay, so we need to do the test, right? So just a minute. Okay, guys, sorry, I'm back. So question 9 says there is insufficient evidence to conclude that the average daily price has declined at a 10% level of significance. So my A is 10%. To be able to make that conclusion, I need to calculate my critical value and my test statistic. So it's a one-sided case. You only have less than. It's not an not equal to case. So my significance level is 10%. So the probability, so let's see, are we given, you're only given the mean, not the standard deviation. So meaning I'm reading from the T. So T, and they believe that it is less than T, and it is 10%. So T is going to be equal to, I read from what degrees of freedom? From 24 degrees of freedom. No, from 35 degrees of freedom. Degrees of freedom is going to be 36 minus 1, which is 35, at a 0,1 rate, right? 0,1 probability, I mean. So I go to my T table, and I read from 35 degrees of freedom, and I read 0,1. So it's 1,3062. 1,3062. But it needs to be minus because it's a less than, and in the T table I need to work with greater than. Okay, and then what is my critical value? So remember, for this one, for question 8, I am working with where the variance is not known. Okay, so the test score is gonna come from here. Okay, the video is so long, guys. I'm trying to save space. That's why I'm like rushing, because it might cut me. So T is equal to x bar minus mu 0 over s over the square root of n. And it's gonna be, okay. Okay, so my x bar is 252 52 minus my mu, which is 260, over my sample, which is 24, over my sample standard deviation, over my n, so the square root of 36. That should give me, so I have 252 minus 260 over 24 over the square root of 36. That gives me -2. So remember that the biggest number is the smallest one. So the calculated t is less than the critical. Therefore, we fall within the rejection, fall within reject region. Therefore, reject H0 in favor of H1. Okay, so remember, what is our H0? Our H0 is that it's equal to 260, but H1 is that it is less than 260. Okay, so H1 is that it has declined. So there is sufficient evidence to conclude that the average daily price has increased. No, there is sufficient evidence to conclude that the average, no, not changed. There is insufficient evidence to conclude that the average daily price has increased at a 10% confidence interval. Okay, there is sufficient evidence to conclude that the daily production has declined at the, yes, C. I would say C. Question 9, C. Okay, let's go on to the last question. You guys come for me whenever I write the wrong answer here. So let me just confirm what the answer should be. Oh my, oh my, oh my. Oh my, oh my. In a room for light. Okay, yes, C. Okay, question 10. A market researcher believes that the proportion of people that are aware of a particular product differs from 0.32, right? So someone believes that it's different from 0.32. That gives me my P0, right? Because they are saying it differs from what we generally know to be true. So 32%. In a random sample of 30 people, so N is 30, 24 say that they are not aware. So P hat is that 24 out of the 30, so 24 over 30 say that they are not aware, right? If the 99% confidence interval for the proportion of people who are aware, how many are aware? So 6 out of the 30 are aware. So they say that if the 99% confidence interval for the proportion of people who are aware of the product in the population is given by this amount, which one of the following statements is incorrect? Okay, there is insufficient evidence to conclude that the proportion of the population that is aware of the product differs from 0.32. Okay, so what you have to do is to check if H0 falls within the interval, right? So the interval is 0.0119, 0.3881. So my H0 is 32%, which is 0.32. Let's put this into 2 decimal places. 0.01, 0.39. So does 0.32 fall within the interval? Yes, it does. If it does, we fail to reject H0, meaning we reject H1. Okay, so there is insufficient evidence. Okay, there is insufficient evidence to conclude that the proportion population that is aware of the product differs from 0.32 at a 1% level of significance. Yes, that is true. So A. Okay, let us quickly mark so that I fix my errors right here before you guys crucify me. Okay, so number 10 is A, number 9 is C, number 8 is D, number 7 is B, number 6 is C. Okay. Oh. Number 5 is A. Yes, number 5 is A. Number 4 is C. Number 3 is A. Yes. Number 2 is B. Yes. Number 1 is A. Yes. Okay, guys. Thank you so much for watching. So this is the end of set G, test 4. Please don't forget to comment, like, and subscribe. Bye, guys. Good luck for the test, by the way.